video comes out good for you guys. This we're running into, it's about 30 degrees outside. 410 refrigerant. We're condensing at about 40 degrees Fahrenheit and dropping. And our suction is really low. So there may be a deeper issue, but the first thing we're going to do is install a fan cycle switch. So what we're going to do is we're going to install fan cycle switch on our liquid line. We're going to make and break the switch with a relay that's going to get power from the cooling side of our contactor that you can see is actually pulled in right now. So we're going to shut off power on the inside to kill all our 24 volts. As you can see, the contactor is no longer pulled in. So we have our 240 volt shut off, supplying line voltage to our motors. And we have 24, our control voltage shut off from indoors. All right, so the first thing is we need to install a T, so we still have a gauge port and another side for our fan cycle switch. And what was previously installed is a manual reset high pressure switch. So if this coil were to ever get dirty, this system will cut off at 610 psi, plus or minus 15 psi. So I'll get these T's installed and then I'll come back. Another thing I wanted to point out, so you see here we don't have our Schrader depressor. There's our Schrader, so that's no good. Luckily, it looks beat up, but it'll work. There's our Schrader depressor right there. So I took the Schrader out of one side. So basically, that will be going into the system. We'll have another T here. Schrader, just like that. We'll have our switch on one side for our high pressure. We'll have our fan cycle on the other, and And then here, we can attach our high pressure, our high side gauge. That's the setup we're gonna have. Now a little bit about this fan cycle control. $275,350, which means if we open this, $275,350, the second one from the bottom. It'll open at 275 and close at 350 psi, plus or minus 15 psi. So we go to our PT chart, we look at 350 psi converted to a temperature. That'll give us around 100 degrees Fahrenheit for R410A, and an open pressure of 275. So when the system falls below 275 psi, it's going to turn off the fan and open the circuit. When our system exceeds 350 psi, it's going to close the circuit and kick on our fan motor. This is the relay that's going to handle the duty, the amperage from the fan motor. So, we have our fan cycle switch attached. We have our manual reset high pressure switch attached. Look at our connection diagram. Outdoor fan motor is fed from a black wire on common. Same as our compressor. Black wire from common. From testing it earlier, first I pulled this black wire, kicked power on, and the fan still ran. Then I pulled this wire, kicked power on, the compressor started, but the fan would not run. So this is our black common wire that sends power directly to the condenser fan motor. We're going to be switching it from that switching relay with the control from our thermostat and the control from our fan cycle switch. So two things have to close in order for this fan to run. One, the thermostat indoors has to close to send power from our transformer to red. And two, the other thing that has to close is our fan cycle switch. So power's gonna come into here. It's gonna hit our contactor, come out of the contactor. It's gonna hit the fan cycle switch. Then from the fan cycle switch, it's gonna hit the fan. So we'll go over that. All right, let's break this down into parts. So first, let's go over the high voltage. That's the simplest factor we're dealing with. So remember this black wire right here for the fan. So whenever the contactor pulled in, it would send power and energize the fan, and the fan would run whenever the contactor would pull in for a call for cooling. So what do? We took that wire for the fan that sends power to the fan, we took that off and we put it to terminal 4. Right there, terminal 4. All right, power coming from the contactor is terminal 2. So you can see that 5 and 4 is normally closed. 2 and 4 is going to be normally open. So when we get power at 1 and 3 on our coil, which is the bottom, 2 and 4 is going to close, and 2 is where our fan motor wire was. It's going to send power when it closes to our fan motor. And what that's doing is, instead of this little switch handling the amperage for this motor, now that switch is just a control, just like a thermostat. It's a control for this relay. So let's go over common wiring of our low voltage. So we have white from our transformer, or neutral, and we need this to feed every coil on our system. So we have 2 coils. We have a coil in our contactor relay for the compressor, and we have a coil in the fan relay for our condenser fan motor. So common comes up, feeds one side of our coil for our condensing fan motor, feeds one side of our coil for our compressor contactor. This is where it gets interesting, because remember, we want this contactor to run off the thermostat, but prior to that, if we have a high pressure situation, we want this pressure switch to pull this contactor out and disconnect it from the circuit. So because this is a switch, we're only going to switch one side of our contactor. We can either cut common in half, and we can switch common on and off, or we can quit our line off and we can switch that on and off. So that's what we're going to do. We're going to cut on and off our 24 volt line. All right, so here's our next step. So what do we have so far? We have 24 volts from the thermostat that's going to go into our manual reset high pressure switch, out of the manual reset high pressure switch, into our contactor coil for our compressor, out of the contactor coil for the compressor. It's going to feed our fan cycle switch. Out of the fan cycle switch, it's going to feed our fan relay. All right, so just to review that, power from the thermostat. This is going to be closed, our high pressure switch. It's going to immediately send power to our contactor coil. When our contactor coil for the compressor pulls in, it's also at the same time, because it's piggybacked, going to send power to the fan cycle switch. Then out of the fan cycle switch, it's going to send power to the other side, the 24 volt side of our fan cycle switch relay. And that's it. That's all of our wiring. All right, let's break this down one final time. Power from our thermostat goes into our high pressure switch. Out of the high pressure switch, feeds this junction, which is going to feed 2 things. It's going to feed our contactor for the compressor, and it's going to feed the fan cycle switch for our fan motor. Out of the fan cycle switch for the fan motor, it's then going to feed our fan relay. So with the high pressure switch closed and our thermostat calling, it's going to run the compressor. If the high pressure switch opens, it's going to shut everything down because the thermostat hits this first. This is going to be closed. It's going to run our contactor. Once our contactor pulls in, it's going to send 24 volts to our fan cycle switch. If it's really warm outside and our pressure is above our cut-in, it's going to send power to our fan relay. That's going to close. That's going to send line voltage from the contactor to the fan motor. Let's see it in action. Just so you guys know how to actually size these relays. So we're switching our fan motor, single phase. That's the PH, single phase, quarter horsepower, 60 hertz, 208, 230, 1.52 FLA, full load amps. Remember, LRA is locked rotor amperage, so that's when it first starts up. So for our compressor, we have 150 amps for locked rotor amperage and an RLA of 25.6. So our fan motor, because it's a light duty load, it just gives us the full load amperage of 1.52. So in order to make sure our relay is properly sized for that, let's focus. All right, 208, 240, 25 amp inrush, 8 amps continuous. So this relay is properly sized for this motor. All right, our thermostat delay finally ended after 5 minutes. Let's kick this baby on. About 30 degrees outside. Going to close at 350 psi. I'll resume recording when we get a little closer to that number. So, TXV replacement now. We're going to do a little trick. I wired the thermostat straight to the contactor. We're going to shut off our king valve, aka the liquid line valve. This is only one king valve. Suction, come down, time it right, shut the power off. Liquid line is shut off. It's going to suck all the refrigerant back from the line set. From that point, suck it all the way back. I back this down to about a quarter turn open. So I backed that in, left that about quarter turn open. With that isolated, the compressor is going to push all the refrigerant into the condenser. It's going to back up in the condenser. And the suction is going to grab all the refrigerant from that point on, through the coil, back through. I left that about a quarter turn open until it got to about 10 psi. Once it got to about 10 psi, I closed it fully. So now, instead of recovering the whole charge, we just recover about 10 psi from the circuit. Now, we can replace our expansion valve.